Hello students, now let us see the derivation of Dalton's law of partial pressure. Right students, Dalton's law of partial pressure. Okay, so what we have to do here, Dalton's law of partial pressure, he is saying that is total pressure. He said that is total pressure equal to sum of partial pressure of component components gases. This is the law. So what is the total pressure? So P total is equal to what, student? That is P1 plus P2 plus P3, and that is whatever it may be other gases, right? Up now that is the where we can write where this is the first convention, where P1, P2, P3, these are partial pressure of what? These are partial pressure of what? Partial pressure of component gases. Component gases A, B gases, 1, 2 and 3. They are the partial pressure of the component gases. Okay, how can you derive this more in deep? So that is from ideal gas equation. So from ideal gas equation, what we can write, student? You say that is PB is equal to nRT. Okay, so for gas A, for gas 1, what we can write, that is P1, and this all the gases are there in the same container. So P1 is equal to N1 RT by V. Okay, this is because volume is fixed, student. If it's P2 is equal to N2 RT by V, that is 2, and P3 is equal to N3 RT by V, that is equation number 3. Okay, now student, now what we can say, put this P1, P2, P3 value in this equation number A. Okay, so from equation A, A and 1 comma 2 and 3 equation. Okay, so let us put the value in this, student. So P total is equal to we can write that is N1 RT by V plus N2 RT by V plus N2 RT by plus N3 RT by V. This 3 equation we kept out here. So what the common things we can get it from here? Okay, so that is common thing is there, student. If you see, that is RT by V is common. RT by B is common. What is not common here? N1 plus N2 plus N3 is the same. So that is what we can write, student, N1 plus N2. So on dividing, what we can get, student? So okay, so therefore partial pressure, what we can write, student? If you want to write the partial pressure, so this suppose equation number 5, and okay, so partial pressure on dividing Pi by total, on dividing Pi by total, we get Pi by total, we get what we get, student? So Pi by P total is equal to N1 RT by V total divided by what? N1 plus N2 plus N3, okay, and RT by V. Okay, student. So that this RT by B and student and RT by B is cancelled out. So what is left out, student? That is Pi, or that is you can say P1, better, P1 upon P total. P1 upon P total is equal to N1 upon N1 plus n2 plus n3. Okay, n1 plus n2 plus n3. Okay, so that is, we can write here is pi upon p total, pi upon p total equal to n1 upon n total, nt, n, no, n1 upon n total. Okay student, we can write that is n1 upon n total. Don't get confused student. N1 upon, this is what, total, so n total. Now n1 upon n total is mole fraction. Okay, mole fraction we have already studied. Moles of one component, moles of one upon total moles. So what we can write is, student, pi, no, pi means p1 upon p total equal to mole fraction, that is x1. So p1 is equal to, that is x1 p total, x1 p total, p1 is equal to x1 p total. This is, and if you talk similarly, if you talk about p2 is equal to x2 p total. Okay, this is there. If you talk about, that is p3 equal to x3 and p total. This is, so this is all about the relations between, okay, mole fractions, total pressure and partial pressure of the gases. Thank you so much for watching, friends. We will study the next question based on it in the next video. Okay, thank you.